All right, so look up, please. Look up. Let's look at carbonium ion, please. I said, by definition, carbonium ion is an organic cation in which the positive charge is located on what's there? A carbon atom, right? Under types, there are three types of this, of carbonium ion. The first type is called the primary. The first type we have primary carbonium ion. Primary carbonium ion, right? And I said for primary carbonium ion, a primary carbonium ion here, the carbon atom which carries the positive charge is only attached to what there? One alkyl group, or what there? Just hydrogen. So here the carbon needs for bonding. This we have this. So the carbon which carries the positive charge is attached to just what there? One alkyl group or just hydrogen. That's number one. Number two, secondary carbonium ion. Number two, secondary carbonium ion. Take down, please. Here, the carbon which carries the positive charge is only attached to two alkyl groups. The carbon which bears the positive charge is only attached to two alkyl groups. Let's call this R1 and R2. Where R1 and R2 are alkyl or aryl group. All right, either alkyl or aryl group. Number three, tertiary carbonium ion. Just use this. So for tertiary, here the carbon bearing the positive charge is attached to three alkyl groups. So the carbon bearing the alkyl, this is attached to three alkyl groups. Let's call this R2, let's call this R1, let's call this R3. So three alkyl groups. Again, R1, R2, and R3 are alkyl or aryl group. This one can be this or can also be written as this one alkyl group, that's aryl to CH2 and then plus. Look up, please. Now, what to note about carbonium ion is that they are cations, meaning they are positive charged or positively charged. Yeah? And difference between primary, secondary, and tertiary is that for a primary carbonium ion or for a primary carbon, the simplest term there is just primary, secondary, and tertiary carbon. A carbon is said to be primary if it is attached to just one alkyl group and hydrogen. That's the carbon bearing the positive charge is attached to just one alkyl group and hydrogen. Or you have this, right? That's alkyl. This is one alkyl group or just hydrogen, as we said. It's called secondary if that carbon is attached to two different alkyl groups or aryl groups. It's called tertiary if the carbon is attached to three different alkyl groups, as it may be. Now we know about alkyl groups. What's an aryl group? I'll take examples for this, you get it, but hang on. What's an aryl group? We know the alkyl group. We know that the alkyls, I'm going to say it's alkyl. The alkyl group is gotten from the alkanes. by the loss of one hydrogen. So when you have alkane as CH4 methane, the simplest member here is what there? CH3. What's the difference here? One hydrogen is missing. This is called methyl. This is for the alkyl group. For the aryl group are a group of radicals or group of compounds that are got from the aromatics. To get your alkyl group, the alkane has to lose one hydrogen. To get your aryl, the aromatics have to lose one hydrogen. So an aryl group is simply a group of compounds that is got from the aromatics by the loss of one hydrogen. What's the most popular aromatic? Benzene. The most popular aromatic is benzene. So the aryl is from the aromatics that got from the aromatics by the loss of one hydrogen. The easiest of aromatics, as we know it, is C6H6, and that's what there? Benzene. If benzene loses one hydrogen, what would it be? C6H what there? This is called what there? Not phenol. It's called phenyl. It's called phenyl. Phenyl and phenol are not the same thing. This is phenol. Phenol is an alcoholic benzene. Oh my God, I'm preaching good. Preaching good. Phenol is an alcoholic benzene. When you have benzene with an OH, it's called a phenol. This and this are not the same thing. Toluene is when benzene has CH3. But let's not go there. Let me teach you how you can use this to name compounds. Let me digress. I'm digressing now. But let me teach you something. Oh, which likely? C6H5. Look up, please. Let me just show you how this works in practical terms. If I have this, so look at this. Look at this. Look at this. How do you name this compound? How do you name this compound? This is benzene, yeah. But what you have is now what is called an aryl group. So the same benzene structure. The difference now is that one hydrogen is missing. Now that missing hydrogen now will now be combined with this. So you now have this. So how do you call this compound? This is 1, 2. So this is phenyl because of there. 2 phenyl. 1, 2, 3, 4, 5, 6, 7. 7 is what there? Hept. What's your parents in there? Alkane. Single bond. So this is called 2-phenyl heptane. That's that compound. So this is an aryl group in action. Let me just show you how it looks like. So C6-phenyl is C6H5. That's the it's almost like benzene. But in this time, or at this point here, benzene is acting as a substituent. You don't say 2-benzene, no, it's 2-phenyl. Right? So you have 2-phenyl. I'm just trying to show you how it works. Now back to what we're doing. Back to what we're doing. Basically, in this stuff here, we want to look at the concept of how to know if a carbon is primary, secondary, or tertiary. From that, look at something called chiral centers and chiral carbon. From that, we see how we can form the number of stereoisomers from chirality. So it's a sequence. Let's start with this first. All right, so we copy this down. Let's proceed. Take down a note and let's proceed. S/B notes. It's not complete, right? There's no space there. No problem. Don't worry. That was not the focus. It's not complete, but don't worry. I just want to show you something. Note, please. The hydrogens of the primary, secondary and tertiary carbonium ions, the hydrogen, write this way, the hydrogen or genes, this way, the hydrogen or genes of the primary, secondary, and tertiary carbonium ion, the hydrogen or genes of the primary, of the secondary, and the tertiary carbonium ions are referred to as primary, secondary, and tertiary hydrogens, respectively. Are referred to as primary, secondary, and tertiary hydrogens, respectively. This is how you write that. I point E, primary, this secondary and tertiary hydrogen. So look up, please. In organic chemistry, if you see this means primary hydrogen. 1 raised to power O. It's called, so this is red, primary hydrogen, secondary hydrogen, tertiary hydrogen, respectively. Let's take a sample problem. Let me explain the concept of primary, secondary, and tertiary carbon. Sample problem, identify the primary. Sample problem, identify Okay, I'm teaching now. Let's start with something easy. In this case, they will ask you to identify the number of primary, secondary, and tertiary carbons you have in this stuff, right? That's like the concept. Let me get the exact questions. Okay, take down. Let me give you the exact questions. Given the molecule, how do you call molecule? Given the molecule below, identify the number of primary, secondary, and tertiary carbon atoms. Identify the number of primary, secondary, and tertiary carbon atoms. Identify the number of primary, secondary, and tertiary carbon atoms available. Carbon atoms available. Also find out how many primary, secondary, and tertiary hydrogens are available. Also find out how many primary, secondary, and tertiary hydrogen atoms are available. So listen please. Our task here is very simple. How many primary carbon do we have in this structure? How many secondary carbon do we have in this structure? And how many tertiary carbon we have in this structure? Now, aside, let me say something before we start. Aside the primary, secondary, and tertiary, there's something called quaternary. Something called a quaternary carbon. Look at quaternary, much more later. Please look at this. The first thing you want to note is that all the carbons at the extremes are always primary. All the carbon atoms, I think it's something that you should note. All the carbon atoms at the extreme are always primary. Yep. All the carbon atoms at the extremes, the extreme means the end or the beginning, whichever one you want to start from, at the extremes are always primary. So I'm teaching this now. Soon I won't do this again, but I'm teaching this one now. To help you visualize this concept, let me draw it out in full. So at each of the vertices, we have a carbon. Carbon here, carbon here. So look at, let me draw it here. This is to help you visualize. The next example, I might not do this again. Just watch. Carbon there, that's this. Upward this way here. We have carbon. This, so this is for this. Okay. Coming down to a carbon, so I have downwards to carbon. Going up again, so going upwards to carbon. Coming down again, coming down to carbon. I have a methyl group, CH3 here. So at this point here, let me just put this way. So I can take this one here, CH3, that's C1, 2, 3. That's the methyl group here. Let me try to balance this one here. This is C1. Can I put H3 here? Is that okay? CH3. So this is 1 plus 3, 4. This one has 1, 2. I'll add what there? Do I add H2C or CH2? Whether CH2O or H2C is correct. This has 1, 2, 3, 4. This one has 1, 2. Again, I can choose to do this. It's still correct. So whether it's CH2 like this or H2C, it's correct. It's correct. But let me maintain uniformity. If I'm using H2C, let me maintain the H2C uniformity, please. This one has what there? 1, 2, 3. What will be here? Just H, 4. Please. The carbon here. 1, 2, 3, 4. This one here. 1, 2, 3, 4. This one here. 1. H how many? H3. Let's identify which of them is primary. I said the carbons are the extremes. Where are my extremes? Let me call this carbon. Let me call this carbon A, carbon B, carbon C, carbon D, carbon E, and carbon F. Carbon A, is it primary? How do you know? Simple. If carbon A is attached to only one group, one alkyl group, it becomes what there? Primary. Listen. If I look at A here, let me draw A in full. In full, A will be this. H3, that will be 1, 2, 3. Observe that the carbon here is attached to what there? Only one alkyl group, which is all of this. Yes, I know that this is not a perfect alkyl group, but get the concept. It's attached to an organic substituent that is not hydrogen. So this becomes what there? Primary. Come to this man here. This carbon here has what there? 2 hydrogen. But observe that this one here is attached to what there? 2 different alkyl groups. You have this one here, which is 1. You have this one here, which is what there? 2. So it becomes what there? Secondary. Come to this carbon here. Please look at this carbon, please. Aside the hydrogen, how many different attachments does it have? It has this one here, 1. It has this 2. So it becomes what there? This becomes secondary. This man here, aside hydrogen, how many attachments? 1, 2, and 3. So because what there? Tertiary. 3 knots. This one here has how many attachments here? So becomes what there? Primary. This one here, how many attachments? Just 1. That's aside the hydrogen, just 1. So becomes what there? So listen to me when I say the carbons are the extreme. The extreme end here, the extreme end here, the extreme end here. They are all what's there? Primary carbon. This one here is not at the extreme. It's at the midpoint. All right. So from this, look at this, please. How many primary carbon do you have here? 1, 2, 3. So I have what there? what's here? Three primary, uh, three primary carbons. How many secondary do you have there? This and this. So I have two secondary carbons. How many tertiary do you have there? One tertiary carbon. So I have this. That's about it. Now hang on. That's case one. Case two say we should find the number of primary, secondary, and tertiary what there? Hydrogen. Shift your focus from carbon to hydrogen. Start with this man, please. This is primary. How many hydrogen do you have here? Three. This is primary, this is primary, this is primary. This gives you what there? Three hydrogen here, plus another three from here. What do you have there? Six, plus another three from here. What do you have there? So I have what there? Nine primary hydrogen. Let's get secondary. This man here is secondary. How many hydrogen? This man here is secondary. How many there? 2 plus 2. That gives you what there? Finally, I have this one here, tertiary. This tertiary, how many hydrogen do you have here? So I have one tertiary. That's how we get this done. Don't worry, we'll do a second example, you get it better. But basically, this is how we do primary, secondary, and tertiary, both carbon atoms and hydrogen. Please copy down. Let's proceed, please.
Alright guys, don't forget that you can get the complete organic chemistry course on my website. Simply visit www.jonahemmanuel.com/courses and then you see the organic chemistry full course. Alright, it gives you access to my detailed lecture on all the homologous series from alkanes, alkenes, alkynes, alcohols, ether, esters, including their nomenclature, their preparation, and all the reactions they undergo. Alright, or you can simply join my organic chemistry channel membership to get access to these video lessons. Alright.